Good morning. Today we're going to be looking at how to develop a project using C++ in Eclipse. We're going to go over the basic settings we're going to be using for that in class as we set that up. As you can see, we are in our C++ perspective. Notice it by the little C/C++ over in the top right. And because this is the beginning of the semester, you can see I have no projects listed over here in my Project Explorer. Let's go ahead and start by creating a project in C++ to first. We need it with Control Enter Command N on a Mac. We're going to choose a C++ project for that and go ahead and go to Next. When we set up a project, we're going to use our default naming convention where we separate all our words by capital letters instead of using spaces, so it'll fit within GitHub very easily. And so this will be our first C++ project. And we're going to choose an empty project for the project type in that drop-down section. In our toolchain, we want to make sure to choose the appropriate toolchain for our development environment. I'm on a Mac box right now, so I'm choosing Mac OS GCC. If I'm on a Linux box, I choose the Linux GCC or regular GCC. And if I'm on a Windows box, I choose the MinGW GCC. Again, not choosing a Microsoft or the Cross GCC compiler for that. Go ahead and choose the Next button to move to the next step. We want to make sure that we are choosing both the debug and the release modes of our code, just in case we need to make any other changes for that as we develop our project itself. Then we'll go ahead and hit the Finish button. When we first create our project right here, we have very little inside. If I click on the triangle next to it, as you can see, all I have are the includes, not anything for the actual project itself, but we want to move on and keep going from there. So what we want to do first is we want to make our source folder for our project. To do that, we right-click on our project, go down to New, and from the New section, we choose our source folder. We'll keep our standard naming convention we've been using for Java for that. All of our sources inside the src folder. Pretty easy to remember. Hit Finish, and you can see that we have a source folder listed here for that project. You can also identify as a source folder because it has that little C right here in the top right corner of the folder icon in the Project Explorer. We're going to do the continue with our model view controller structure that we've used throughout Java and Swift in our project. Instead of using packages though inside C++, we'll simply be using folders for that, where the packages come from. And so we right click on our source folder inside the source folder itself, and we'll go to New, choose the option for folder, and we'll make a controller folder. This is where we'll put all of our controller components, aka the actual app controller itself and the runner for our file. And then in our model folder, we'll put any of our model components we'd use. And then in the view folder, we put any of our stuff we use to actually see the actual results of our code. Right now, we're not going to be worrying about that for the basic structure though. But just to get the idea of process, what we're doing, we're getting that set up for us right here. We're then going to go over in our controller folder, we're going to make our actual starting part of the project, which is our main. We'll put our runner file. So we'll right click on there, go to New, and we'll make a new source file. This is going to be our Runner.cpp. So the Runner.cpp saying it's a C++ extension. We're going to go ahead and hit Finish for that. It's inside our controller folder, which is inside our source folder. Easy to remember where we're at. We hit Finish. I'll expand out the documentation comments that are built automatically. We see this is just Runner.cpp created on the 12th, 2016 by myself. We're going to go over here, and starting after that, we'll get the beginnings for it. If we're going to make just a default folder, it's just going to be our main file. So we do int for our keyword to start off what return type we're doing, and then main, parens indicating that's a method, and open and close squiggles to indicate that we have that ready to go. And to simply make a compilable project, we simply have return 0 as the line of code for that. We've now got this set so it's ready to go. We could actually build and run this immediately. So we'll go ahead and hit Save to save that, and Command B to build. It builds all. As you can see right here, we have over now in our project, we have a new folder called debug. On that debug folder, if I click down on there, I have a source folder again, and then the first C++ project, it's an x86_64, aka it's compilable for the 64-bit system for a Mac. I can right click on this and run it. I go to Run As and choose a local C++ application. And we have right here an application that does absolutely nothing because all it does is simply returns 0. It compiles and runs appropriately but does nothing. We'll go ahead and close that off because we really don't need to keep that up there. And we can go ahead and close that screen as well. Maximize that out. And what we want to do now is we want to actually make this so we can start learning how to do the beginnings of using that model view controller using C++. To do so, we're going to go ahead and we're going to leave that debug folder alone for now. We're going to go back to our controller folder and we're going to right click on this. And we're going to use this the long process way first, and then we'll look at doing it another time on how to use the little short version. So we're going to right click on that. We're going to make a new. We're going to choose a new header file. and we're going to call this simple controller. When we're doing the idea of a header file, we want to make sure that we have the naming conventions basically set up so that we have the name of the class itself, followed by a .h for that .header extension. And we'll go ahead and hit finish right there. And so our header file, we have some basic structures we're going to take a look at. Again, our default documentation comments, we'll just set that up, really no big deal. We'll close that down. We don't need to see that right now. But the header files themselves start with some basic information we want to take a look at. The first thing we have is the pound if and def. This says if it's not been defined, aka for the control, what we're working right now, and then we will define that. And this is allowing us to keep so that we have our different header files are defined appropriately throughout our project. And our file itself will end with pound endif. And so all of our header files will have that as the basic extension. We're going to go ahead and get this first part started. So the first thing we have is our keyword class, and then we'll give the name of the class, which is simple controller. And our class has, unlike Java, we don't have the keyword public in front of it, and we also notice that we have right here at the end of the class, we end that with a semicolon for that definition. We'll then have that is all included within that pound define / pound endif. So those marks right there are the preprocessor marks that define this actual class itself. We'll go ahead and hit save on that. And so we have our beginning of that saved at this point. And what we need to do at this point is we're going to go ahead and we're going to add to this project a public section. That public section means it can be called externally. And so we'll go ahead and use the public keyword right here, a colon, and that notice how the indentation happens afterwards. So we're going to have a defined constructor as well as a public method for this, just to get something started with that, as well as a going from there. So we have a constructor. The constructor follows the same approach we were using within Java, where it's the same name as the class. And so we'll have a public simple controller. And it's going to be a default constructor with no parameters. And we'll have a void method called start, like we've been using throughout the year inside our Java program, simply to start our code. And those happen inside that public section. These are visible outside of the class. When we hit save on that, again, it's always a great way to save. Again, at this point, it'd be a perfect opportunity to put this inside your GitHub and get that put into your appropriate repository. So we have right now a class simple controller. It's defined with that if and def to get that started. It's inside our simple controller.h or our header file, which has these two formats in there. Notice that there is no code attached to this. This is simply the prototype or the header for those methods and constructor. So we need to, at this point, also write our implementation file, which is the .cpp file. So we're going to do that. We're going to keep inside our controller folder. We're going to right click again on this, go back to new, go back to our source file. And this is going to be simple controller .cpp. So again, it matches the .h file, so we have that same approach. We'll hit finish on that. We have our documentation comments that immediately start off with that. And the first thing we want to do inside our simple controllers, we're going to want to get a reference to that. To do that reference, we use the pound include. And then because it's a personal file when we create it ourselves, we're going to use the double quotes for that. And we're going to refer to that by going to simple controller.h. So we're referring to our already defined class called simple controller.h. I'm going to go ahead and close this window out completely. So we have access to that code so we can see that a little bit better. And so in our pound include, we have that right there. And the structure for writing a class inside C++ is a bit different from that of Java. And so in our, we saw that right here with that header file that we were using right here for making that class. The implementation for that class happens over here in the CPP file. The first thing we have is that pound include. We're also going to do right here, we're going to add a reference to this so we can have that going. And what we need to do on that is we're going to do a name of the class. In this case, it's going to be simple controller. And then we'll use the double colon for the scope resolution marker. And we're going to refer to, as you can see right there, it's pulling up automatically because of Eclipse. We need to refer to our constructor, simple controller. And right now we have the beginning format of our class. The simple controller constructor is inside simple controller as a class. It uses that scope resolution for that. We'll go ahead and hit save on that so it's simply ready to go. And then we're going to also do our same thing for our start method. So it's going to be the class is simple controller. The scope resolution to indicate where it is, it's going to be in the start method. and again our open and close squiggles to identify that this is a method that belongs to that. And we have to also prepend this with the keyword void because it is a void method. So we identify that this one's a void method by putting void before the name of the class and its scope resolution to method name. And right now, this will compile and be good right here. It does very little. In fact, it does absolutely nothing. Starting over here in the runner, we notice that all it does is return 0. There is no reference whatsoever in our runner to simple controller itself. And our simple controller.h and .cpp are simply empty headers and empty methods that do nothing. But let's check this out. Let's do ahead and go to Command B to build this. It builds all. I'll go ahead and on my view down here, we'll pull up my lovely little console window. And we can see that we have on that build, we've invoked that. All of our files are saved. We invoked that. We build all of the messages. And we build our first C+ project from the source folder with runner.o, simplecontroller.o. So we built those two files making a project with that, and nothing happens. It simply is there. And I can go ahead and also run that as well by going over here to my debug, right-clicking on first C++ project, and going to run as and choosing local C++ configuration. And again, my program runs with nothing happening because my program does nothing yet. Let's go ahead and let's make this so it can do a little bit more with our project. We've got the framework for it right here inside our constructor. We're going to go back to our Runner.cpp. And inside our Runner.cpp, the first thing we're going to do is we're going to build a reference to our simple controller object, just like we've been using inside Java. So what we're going to do is inside the int main, we're going to do a reference to it by saying that we're going to make a simple controller object. And we're going to make a pointer to it using the pointer indicator. The pointer operator is the asterisk right there. And we will call this base controller. And it's going to be a new simple controller, semicolon. So we've created a reference to our simple controller. We're using a pointer indicating that we're using a pointer for that object. And then our next line of code, we're going to call base controller. And then we'll use the arrow indicator or the selector and start. So base controller, oops, if I spell correctly. So our base controller is going to call the start method. We use the arrow indicator on this because we're calling the method on a pointer. We can also do this with a more formal way on that. So I could simply put this on here. And we can do that with a separate method of doing that, but we'll do it right here with using the arrow indicator because the method is off of the base controller pointer object that we're referring to. And we're going to rebuild that project. And we now have an error message in here. This did not compile. If we go over and hover over our lovely error message, we have an unknown type simple controller. We typed it, we know we wrote it up here earlier, but there's no reference to it inside main. We need to have a reference to that controller. We did this earlier when in that we already did that pound include simple controller.h is how we understood that there is a library of code attached to simple controller that we can reference that happens to be inside that controller folder. To do so, we need to do that same thing over here inside our main file. And so we'll do the pound include. And we'll refer to that simple controller by doing quotes. And then inside the quotes, we'll refer to simple controller.h. So we've saved that right there. We haven't made any changes to our controller.cpp or our controller.h. Those are still basically empty files that do nothing. We're going to rebuild that project. And as you notice right now, we no longer have an error message attached to that. I can go ahead and now rerun that. Right click on there. I'm going to run as, and that's a local C++ application. And I go over to my code, and that terminated effectively right now. And so I've been able to rebuild that project. It does very little. Nothing's happening with that. But we built a project that can compile and run that does effectively nothing the entire way through. Let's add some features to this so we have access to doing a bit more than our project. So our runner now, though, is done. This will be the framework for our runners that we'll be using inside our C++ project, where we have an int main method that has a reference to a controller object. That controller object is instantiated as a pointer. We call it start method, and then we close our project with return 0. So that file is effectively done. We'll go ahead and close that for now, and we're going to go back to our simple controller.h. We're not going to make any changes to this to start off. This one right here is good to go. We don't have to make any changes to it. It's simply done. We'll close that one finally as well. Over here inside our simple controller.cpp file, however, we're going to make some new changes. And so what we're going to do is we're going to learn how to do some basic I/O with this. To do so, we're going to add a couple lines of code to have that happen. And to do that, the first one we're going to do is we're going to do pound include. And we'll use angle brackets to indicate that it's a built-in library. We'll choose IO stream. And then after our other pound includes, we're going to add another line of code. We'll say using namespace std semicolon. And so using namespace std is how we're going to be referring to that. That's going to give us the reference to our standard library. And IOStream gives us access to input and output. To have that happen, we're going to go over here inside my simple controller. When we create our object, we'll give a message to the console, and then we'll do a further message to show that we pass control to that start method. So to do that, we're going to go inside the method. We'll tab inside here. And for output, we use the idea of cout, and then two less than symbols together, followed by a set of quotes, another set of less than symbols, and the keyword endl semicolon. So we have cout blank line endl, and we'll say creating a simple controller. Inside that, so we have a console output line that simply says that we're creating that file. We have the arrow indicators which indicate that we are directing that information to the console output, and this right here indicates that it is ending a line. We have to find some way of closing our lines, and we'll be using this as our standard way of doing it inside class. And so right here, let's take a look at this. We've saved it. We will rebuild our code with Command B, build all. Let's take a look at the results for that and restore that. And as you can see right here, we have made our incremental build, and that changes happen. We've finished building because we changed the simple controller.cpp file. That's the change that we had to make on that. It's building our target for our first C++ project. It called the G++ compiler using -o, naming it first C++ project, and it passes the runner object file. And then inside our source folder, also the simple controller.o, which is the combination of the .cpp and .h files put together by the linker. And it puts it to that target for C++ project. I go over here on my debug folder. I now have that C++ project right here. Again, I'm going to right click on that, scroll down to run as, and choose a local C++ application and run it. And we now have a line right here saying I've created a simple controller. This now prints out that information for us. We're going to continue on with this and show how we can use that information of passing a reference or passing messages using methods right here. As we're going to do another line right here inside our start method, and we're going to use that so that we can show the idea that we have passed information to that. And so we're going to go over here and we're going to do cout again. Angle brackets to indicate that we're using a string. Angle brackets again, and endl to close it all off. And at this point, we're now inside a method. Now inside the start method. So as you can see, we have created that in line right here. So that ends the line and brings it to the next line of the controller. So our next line will print up right here when we do that. We're going to go ahead and clean this project out because we're no longer using it. We're going to rebuild our project. As you can see right here, nothing has to be rebuilt at this point, but we're going to hit build again, Command B, building all. We can see that there was actual changes that were made. So it uses the make all component. It rebuilt on the simple controller.cpp. That was the only change file. We've not made any changes to our other files inside that, runner.cpp or simple controller.ch. We'll only change this one file, adding that one line of code. And we'll right click on this updated version of the file, right click, move down to run as, and go to local application. And we created a simple controller, and we are now inside the start method. Notice that we use that endl to indicate that we're going down to another line. If I did not use that endl, it would simply just continue on with that, and we would have the idea that we are no longer at the end of the line. However, when we're done with a regular cout statement, we want to actually choose the option to choose endl. We want to actually end that line of code at that point. And so endl is what we will use every time we have a cout method. So we've used that idea basic right there so we can actually have that information. It gives us the basics of output using this. We're going to go and add one more feature inside that, And so we're going to go back now to our simple controller.h. And we have inside that public method, we have that start right here. We're going to go through and we're going to use a new feature. For that, we're going to add the private keyword. And in the private, I'm going to say that there's an int, and we'll call this age. Age is a simple, easy number to store into. We have that right there. We'll make another method in our public, and we'll make this called a void method, and we'll do set age. And it takes an int age as a parameter, and a semicolon again. So we're using the idea that we're going to make a setter for this. We have a data member for that class listed in the private section because data members are private and belong to the class itself. A public accessor method for that, using set as its prefix again, and using the idea of age. We're going to go ahead and save on this. We're going to now go down to our simple controller.cpp, and we're going to make a new method for that. It is going to be another void type, and it's going to be in the simple controller class. Its scope resolution will be set age, and it takes in a parameter of int age, again on that. And so we have right here the idea that we're creating a new method with this, and we're going to use this keyword for C++. Though this keyword looks a little bit different, it uses it like we do in Java, it refers to the current object. However, to make this be a little bit special, because it's a pointer reference, we have to use the pointer operator, aka the dash arrow. And so we'll go ahead and tab into this, and we'll say that this angle age, so we're pointing to this age equals age. And so we are going to refer to the age of this object. We'll be assigned that age value, having that defined at this point. We can also use the idea that we can have a value attached to our individual class. We'll go back to our controller.this, and we will say that age equals 9. So we defined a value right here at that, so we have a reference to age. And so we've defined the value for it inside our actual private section. So 9 is what the value is. When I call set age, that'll override that value. And we're going to see how that works inside our code. So in our simple controller right here, we've created a simple controller. We'll add a new line right here for another cout statement. So cout statement, and then angle brackets. And we're going to refer to this age. So I'm going to print out, after I create a simple controller, this age. I'm going to use my start method, and that will make it so I'll do inside the start method. And inside here, I'm going to call set age with the information for that. So to do that, I'm going to say another int. I'll do a temporary. So I'm going to grab console input, and I'm going to put that into temporary. And then I'm going to set the age using that temporary variable. So I'm going to go this set age temporary. And I'm going to cout my age. And as you can see, I'm using the idea of these angle brackets on cout, combining them across this. So I'm going to grab that temporary variable. That's console input will be shoved into that. I'm going to take that temporary variable that I just grabbed. I'm going to set that information in as the set age parameter, which will come down to here. And then I'm going to set that new age, passing it that age. So to see that in action, we're going to go ahead and save that file as well. We're going to do Command B to build yet again. We've built that. And we're going to right click on our project, go down to Run As, choose Run as a local C++ application. So we've created a C++ a simple compiler, 9. We're now inside the start method, and it's now waiting for input. We can see that it's no longer stopped. It's actually running right now. It's waiting for information. I'm going to type in a clearly different number than 9, 1, 2, 3, 4, and press Enter. And the new age is 1, 2, 3, 4. So it was able to grab that information from the temporary. It puts it into the console input, grabs it, puts it in the temporary variable. It then sets the age, passing it temporary. Temporary comes down here, takes that parameter of age, dumps it from age into this.age, and I am able to put that reference inside that. So we see the beginnings of how we're going to be using the idea of pointers and parameters inside this. It's a very beginning approach, simply just using a setter, doing some console input and output, and we have access to that with a variety of things. So that's our quick little make a quick project using C++. Let's go take a quick review of what we did to make that happen. So over here we have our binary folder, which has access to that as well. We have our source folder. Our source folder made simply just a controller folder. In our controller folder, we made 3 files so far. Our first one is the Runner.cpp. This is going to be our basic format we'll be using throughout the year, just like we did within Java. We have an int main method. Int main is the required method to start programs. It wants to make sure it's a lowercase main. We don't have any parameters inside this at this point. We simply say simple controller. We do a pointer reference indicating that we're creating an object that's of a pointer type. We give it a name of base controller, just like we have inside our earlier projects, and we then call its constructor. We then use that object reference, base controller. We use that pointer reference indicator, the arrow indicator, calling it start method, so we can use that. And then we call return 0, which is the satisfactory into a program in C++. We then built a simple controller.h file. We added some information to it where we first start off with simply some public information, passing a constructor and a method. We added then another method as well as a data member. The data member is private, where it only is accessed internally. And then we use the pound if and def, pound define, pound indif to indicate that this is the actual definer for that, so that we have access to it. We use that pound include inside of runner.cpp, so we can see access to that. We have a reference to a simple controller object for that component. In our simple controller.cpp, we actually wrote the code that we'll be using for that. The first thing we had to do in order to get that going is write the name of the class, the scope resolution indicator, and then the constructor and methods that went along with that. Then we added some code to make that happen, where we actually were doing some console output. For that to happen, we had to add the pound include IO stream, which gives us access to the console input and output for the streams of information. And then we use the namespace std, so we'd have access to the method calls for that. Cout is a console output method, which we'll be using for that. We use the idea on that with the arrow indicators right here to indicate we're going to direct that information to output. Every console output line or cout line ends with an endl, indicating it's the end of a line. And we use those separated. Every chunk that's not exactly that string, we have a separator indicator with another set of the angle brackets in a row. And we've combined those in multiple lines with having it like that. We then continue on with that start method where we were able to go through that. We kept the idea of using that cout endl to keep that O. We also used the idea of declaring a variable called temporary. We then took the information from the console input using cin to get console input. We took the console input and we directed that, to our temporary variable. We then called our reference to set age using this set age. We could also have simply just gone through and just set that age, but we're using the idea of using that pointer reference so we can get used to using that all the time. And then we used a new statement to say the new age is, and then we used a reference now to this.age to refer to our current object again of this, using the this pointer, and grabbing its age variable, a private data member that's not otherwise accessible. By default, as you can see right there, it's showing it's 9. Our setter looks just like that. We have it so it's built in directly. It has a reference on that. And so we've seen now the basics of how to create a class, how to create a runner, how to execute that code inside our environment, and how to put that together and call methods within itself using C++. We'll continue on with that and adding more features and using that model view controller structure we've been doing throughout the year and building more complex projects throughout the semester. If you have any questions, let me know.